Okay, guys, lesson 5. And in lesson 5, we are going to look at energy and momentum part 2. Remember, we said energy and momentum, according to energy, there are two types of collision. We have elastic and inelastic. And you remember how we defined. And yesterday you saw that if you don't know your definition, some calculations become difficult. So definitions goes beyond just cramming a set of words. You need to understand the concept. Once you understand the concept, then you are good because you can apply the concept of the definition and deal with calculations. I promise you guys, grade 12 requires a lot of thinking. So today we're going to do part 2 of that. And in this part 2, I will be working with mechanical energy and how to apply mechanical energy. Why are we bringing mechanical energy? Because it has to do with velocity. And secondly, I'll be telling you when an object changes axis, what happens. Okay. All right. Without wasting of time, let the games begin. First thing is to define what mechanical energy is. And you will see how we will infuse the two. Mechanical energy. This we did in grade 10. Amazingly, in grade 11, this is not taught again. So some of you would feel this is new. It's not new. Something we did in grade 10. Let's start by defining mechanical energy. Mechanical energy is the sum of kinetic energy and gravitational potential energy. Mechanical energy is the sum of gravitational and potential energy. So when we add those two energies together, we have what you call mechanical. Let's quickly redefine kinetic. And so let me do this. Emech is equal to Ek plus Ep. And this is equal to half mv squared. Oh, I should have done something, but it's fine. Mgh. Yesterday we defined kinetic energy. Today I want us to quickly define potential energy. What is gravitational potential energy? I should have done that, but it's okay. It's no stress. No one is going to kill me for doing it now. Gravitational potential energy. It is the energy of an object, let's make it simple. Energy of an object due to its position above the ground. The fact that I am mentioning above the ground means I am therefore talking about height. And you would see your two formulas there. Ek equals to half mv squared. Ep equals to mgh. Ep equals to mgh. Where we know that m is mass in kilogram. G is gravitational acceleration. And it has a constant value of 9.8 meters per second squared. Okay, I'm just going to leave it as that. It's supposed to be downwards, but I'm dealing with energy, so I'm just going to leave it like that. And h is height in meters. H is height in meters. So we have defined all the variables. There's a message. Okay, Rosanna. What is EP? Gravitational potential energy. All right. That was why I said I should have defined that just immediately. So, but sum of EK, sum means addition, kinetic energy and gravitational potential energy. The sum is plus, EK, kinetic. Are we good? All right. So please take note of that formula. We will do this again in another topic called work, energy, and power in term 2. But we need this now. We need this now, quickly. We need this now. All right, so potential energy, MGH, when we add that to kinetic energy, we actually then get what we call gravitational potential what? Energy. Sorry, we get mechanical energy. The sum of kinetic plus gravitational potential gives us mechanical energy. Now, I quickly want to demonstrate something to you. Can I move to the next page? I need to run a bit today. Everyone should be good here now. Let's say your hand is up. Do you have a comment, a statement, a question? Joshua, your hand is up. If you are agreeing, we use the thumbs up. If you are raising your hand, probably you have a question or you want me to explain something. Joshua, your hand is still up. I want to know if it's a mistake, you have a question. Please do let me know. Joe. Okay, Joshua's hand is down. Jabs, your hand is up.
So for the mechanical energy, is this like the new formula?
Mechanical energy is the sum of kinetic and potential. It's not a new formula. It's the sum of two energies.
Okay.
Yep. So we have two energies. We have kinetic, an object is moving. All right. We have potential due to object's position above the ground. If we add the two together, we have what you call mechanical energy. Okay. Let's quickly look at something to help you understand better. So if I were to consider, so that you would see, okay, there's a hand up again. Jojo.
Yes, my question was, back in grade 10 we were taught that energy is conserved. Is it still conserved in grade 12?
Energy is always conserved, whether even in varsity, as long as it's an isolated system. All right, so your grade 10 teacher never lied to you, trust me. It's in maths that we lie to you, guys. In maths, we lie. Can I be honest? Maths, we lie to you. Physics, we never tell lies. You guys are laughing. Maths, we lie. Are you aware that when you were in grade 1, 2, 3, 4, when you were doing maths, and we tell you 5 minus 7, what was your answer? We said impossible. Do you remember? You did that until grade 6. Or even grade 7. Then you got to grade 8. Then someone says 5 minus 7. And then it automatically, answer changes from impossible to negative 2. Like, my maths teacher was lying to me all along. All right. So maths, things always change. Guys, what is the square root of negative 4? You guys are now in grade 12. What's the square root of negative 4? You were taught from grade 8 that there's no answer here. Even your calculator will tell you error. Wait, it's undefined. Thank you, I was waiting. We just lied to you. Sorry. I apologize on behalf of maths teachers that we keep telling lies. One of the best liars in the world, maths teachers. All right. When you get to varsity, you would see 2i. That is the square root of negative 4. Some of you have read, some of you are doing applied maths. You would know what I'm talking about. Okay, so with physics, no lies, pure. Physics is very pure. So, Josh, energy is still conserved. but energy can only be conserved in an isolated what? System. Very lovely question. I love that. I love that. All right, guys, if we look at this and we create a height, okay, we create a height h here. I'll tell you where this is going to play a role. Please, I want you to listen carefully to what I'm doing. I don't want you to confuse yourself, so listen carefully. We have a height h. An object at the top here, all right, dropping to the bottom on the floor. Here, the height is equal to 0. Here, we're talking about maximum height. You would remember, some of you are now beginning to remember this. Okay, maximum height. At the maximum height, at the start of the object, this is the beginning, initial. Object is at rest. It means the velocity is equal to 0. But as the object comes down, velocity becomes maximum. Two things are kept constant. M and G. The mass of the object is kept constant, and the acceleration due to gravity, which acts downward, is also kept constant. Now, as long as the system is isolated, we will then say the law of conservation of mechanical energy. The law of conservation of mechanical energy. You see, I am being specific now. All right? And what will this say? In an isolated system, the total mechanical energy is conserved. All right, you would notice that this is similar to momentum. We're just changing words. Okay, I'm going to call this top, and I'm going to call this the bottom. So we can therefore say the mechanical energy at the top, I don't know if you guys remember this now, is equal to mechanical energy at the bottom. We did this in grade 10. All right? Okay. But what is mechanical energy? It is the sum of kinetic plus potential, but this would be at the top, and this would be equal to, I'm not going to go deep into this because we have another topic where we would be looking into this concept deeply. So I'm just going to quickly pass over it as fast as possible. But we are now following the law. I'll repeat everything I've said quickly so that you make sure you are on the same page with me. If the system is isolated, the mechanical energy will be conserved, right? Mechanical energy at the top will be equal to mechanical energy at the bottom. And when I say the system is isolated, let's revise. We are saying there are no external forces. I remember someone said examples of external force. We said friction. Another external force is applied. Another external force will be tension. All right. None of these forces are there. Your external forces are not there. There's no friction. That's why you would see the questions keep saying, ignore friction. Okay? Tension, there's no rope between two objects. Applied force, no one is pushing or pulling the objects. All right. Thank you, sir. Mr. John, fat forces. Okay. We call them fat forces. Fat forces are external. These are external. We will do this again under work, energy, and power. Fat forces. All right. Now, so we're saying the mechanical energy at the top is equal to the mechanical energy at the bottom. We're going to see why we're doing this. All right. And what is mechanical energy? It is the sum of kinetic and potential. I like to repeat things because I want to make sure it's solid. It is the sum of kinetic and potential energy. Hence, I said kinetic plus potential at the top will be equal to kinetic plus potential at the bottom, or anywhere in the system. All right. Half mv. Since it's at the top and the top is initial squared, plus mg, initial height, will be equal to half mv at the bottom, we talk about final, and mgh final. And guys, it's not necessarily just at the top or at the bottom. It could be anywhere. I'm going to do a small diagram. If I consider this, and it's an isolated system, I have point A, I have point B, and I have point C. What we are saying is E mech at point A will be equal to E mech at point B, and that will be the same as E mech at point C. All right, let me go back to Josh. Energy is conserved, but it can be changed. All right, as the object comes down, it is losing potential energy, but it is gaining kinetic energy. But the gain and the loss, energy is still conserved, mechanical energy. All right, guys, this was great. This is grade 10. Are we okay? Because I want to apply this now, quickly. Blessing, your hand is up. Blah, blah, blah. All right, so this is just a revision of grade 10. But this is where I want you to listen carefully now. I'm going to now take this information and split it in two ways. Please, I'm begging you to listen. I'm going to split this particular information now into two. I'm moving on. When it comes to momentum, remember we said mechanical energy and momentum. Mechanical energy and momentum. This is what I want you to expect. This is the scenario that you would always have in the exam. All right. I have an object there. Is that okay? And I am going to have an object here. Please, I'm pleading with you to listen to what I'm doing here so you don't get confused. This object is like a ball, could be anything. And this object is held stationary here. All right. Now, what we will do, okay, this one here will also be stationary. Now, what will happen is this object will then be released. Once it is released, what happens? It starts moving, right? And do you notice what's going to happen? Let's move this here. This object will then come and what? And collide. Boom. Please, this is now two things. Here, we are talking about collision, which is what we've done. Momentum. Right? But on this part, on the left-hand side, let me use a different, before I ask you whether you are okay. On the left-hand side, we are going to be talking about mechanical energy. Please, I want you to listen carefully. Conservation. So this object has an initial velocity of 0. Once it starts moving down, what happens? It gains energy. It gains velocity. such that by the time it gets to the bottom, we have a velocity. Remember, let me go back. What did I say here? At the bottom, the final velocity is maximum, right? So the initial velocity here is 0. You can, imagine it like you're swinging. Some of us go to the amusement park. You go up, when it's coming down, that's when it moves fast. It gains energy. Therefore, we have a velocity here. And with that velocity, let me do something here. This stationary, I want to move it. We're saying this one here is stationary. Okay. We said here we're talking about momentum. The V of this becomes what? 0. So this object gains energy and then collides with this. So we are doing two different calculations. We are doing mechanical energy on the left, and we are doing momentum on the right. This is the connection between the two. Please let me know if you're okay. Let me know if you're okay. So the examiner will tell you to calculate something. There is a hand that went down there. Is that favor? Favor? Favor, 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 favor. All right, Bongai, I'm going to repeat that. Please repeat the part of the two calculations. Okay, I'm going to repeat. Somebody's laughing again. You guys are just full of laughing, like you have laughing gas. All right. So we have mechanical energy. Remember, we're talking about objects colliding. That's the momentum. So I've got an object. Is that fine? There's only one object. But I have another object that is hanging. I have another object that is hanging. There's a question I was looking for and I didn't find it. I'll try to send it. I'll look for it again. I was lazy. Okay, don't let me lie. I was lazy to look for the question. Let me be honest. Okay. So, but it's in my head. It's in my head. And I'll tell you what the question looked like. Yeah, I'm allowed to be lazy, guys. All right. So, this object is stationary. Favor. But we want this object to collide. Collide with what? Object 1. But object 1 is up there. So, if we release object 1, what's going to happen? It's going to move down, right? Poo, 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 poo. And what happens? It's going to collide with object 2, which causes object 2 to move forward. Favor, let me know if that's okay. I want to carry you along quickly. Is that okay with you? Favor, where are you? Oh, Elisa Favor. Great. Good. Bokan, you good? Bongi, you also good? All right, everybody good. So, but here's my problem. Remember, we said M1 VI1 plus M2 VI2 equals to M1 VF1 plus M2 VF2. This is object 2. This is object 1. Object 2 is stationary, the initial velocity. So this whole thing will be 0, right? But the question is, what is the initial velocity of object 1? Which is the velocity at this point? We cannot calculate that without using mechanical energy. For now, there are other ways to do it, but for now, this is what we're going to use. So we would use mechanical energy to calculate. Don't worry, I'll do a question with you. We would use the law of conservation of mechanical energy to get this velocity here, and that becomes the velocity with which this object 1 collides with object 2. So how would you get this final velocity? We would use the law of conservation of mechanical energy. And then after getting that, we shift to the right-hand side and we look for momentum. Did that make sense now? Did that make sense? Let me see if I can look for one simple question. I've got a couple of complex ones, but let's see if we can look for one simple one to just bring us to speed. Yay. Beautiful. Do you see that? Check. Beautiful question. How many marks? 13 marks. I'm going to do this one for everyone, guys. So please try to, I think this one should be simple enough as a start. I hope we don't find anything complex. So please go along with me. Now you'll be able to find other questions on your own and see an approach to it. A steel ball of mass 0.5 kilogram is suspended. There we go. From a string of negligible mass. It is released, you remember, we start reading with intent to understand. It is released from rest at point A. What does that tell us? That tells us that the velocity here is 0, as shown in the diagram below. As it passes point B, okay, this examiner now is trying to do everything I was doing, which is 0.6 meters above the ground, the magnitude of the velocity is 3. Oh, they are telling us that at point B, the velocity is now 3 meters. Do you notice? It was from 0. It's moving. The velocity is increasing. Why is it increasing? Because it's been pulled down by a force called the force of gravity. We will understand this better again when we do vertical projectile motion. All right. I think that should have been the first topic anyway, but syllabus says momentum. Guys, are you following? All right. Ignore the effect of friction. May I quickly ask, before we go into calculations, do you understand what I have read so far? Please, I need your thumbs up, thumbs down, sad faces, happy faces. I'm looking for somebody with a thumbs down. No one. Okay, so you understand what we've read. Yay! You should see me dancing here. All right. Look at 4.1. 4.1. Write down the principle of conservation. Look, guys, once you see conservation, know that isolated system is involved of mechanical energy. Did we do that? Yes. 4.1. What would I say? In an isolated what? System, the total mechanical energy is conserved. All right. 2 marks. UJ is now looking for you, crying for you to come because you can define. Please come. Don't even wait for Great. Just come. We'll take you. Because now you know your laws. All right. Yeah. Guys, look at 4.2. Calculate the mechanical energy at point B. What is the formula for mechanical energy? 4.2. E mech is equal to, it is the sum of kinetic and potential, half mv squared plus mgh. What is the mass of the object? 0.5. At point B, what is the velocity? 3 squared. What is the mass? 0.5. What is g? It's a constant, 9.8. And what is the height? Now, guys, height is always measured from the ground. Examiners are going to confuse you. Height is always measured from the ground. And our height here is 0.6. Do you want to put this in a calculator for me? Please? Let's test. Quickly. Calculator. Oh, Favor, you got it now. Yay! I love that. I love that. I love that. I'm going to send you a bottle of Coke, Favor. Don't worry. 5.19 says Abigail. Abigail, that answer is wrong. 5.19 is wrong. Saint TK. Everybody's now scared to throw me an answer. Because your calculator is showing 5.19. You guys are now scared. All right. Monati Trinofatu says 7,15. Okay, guys, we have different answers now. Although Sentike also gave me 5,19 joules. So please let's confirm. Trinofatu, why are you having 7,15? All right, Lane, your answer is wrong. Njabulo, your answer is wrong. Funanani, your answer is wrong. Amara, your answer is wrong. Okay, Amala says 7,15 joules as well. Okay. Ifan, answer is wrong. Ofente, 5,19. Answer is wrong. Lumka, 5,19. Wrong. Joshua Pule, 4,01. Wrong. What's wrong with you guys? Come on. All right, let's see. So it is half. 0,5 multiplied by 0,5 again, multiplied by 3 squared, plus 0,5 times 9,8 times 0,6. All right, 5,19. But why am I saying your answer is wrong? Okay, Aline, how is it wrong? Great. I am going to tell you, I think so far I've only had 3 people giving me correct answers. Siviwe just gave me a correct answer now. Let me also give credit to who gave me the correct answer. Sentike gave me a correct answer. Who else? Siviwe. Thank you. SI units. Come on, people. You've been doing physics for 3 years. 5,19 joules. Please. SI unit. Energy is measured in joules. Energy is measured in joules. Please, I'm sure you've learned a lesson there. And those of you that got 7, whatnot, I don't know how you did that. Probably, I don't know. I really can't explain what you did. All right, but guys, are we okay? Check. 4 marks. Beautiful 4 marks. Now, let's go to the next one, 7 marks. As the steel ball swings through its lowest position at point C, my dear learners, I want you to listen. So the steel ball continues at point C, but always remember, as the ball moves down, the velocity is increasing. Okay, you missed the 0,6. Okay, no problem. All right, now listen. As the steel ball swings through the lowest position at point C, it collides with a stationary crate. Now, check. It collides. We are now on momentum. Right? With a stationary crate. A stationary crate of mass 0,1. The crate is stationary. Mass is 0,1 kg. Immediately after the collision, the crate moves at a velocity of 3,5 meters per second to the right. Are you seeing that with the diagram, right? So, no stress. Calculate the velocity of the steel ball immediately after collision. All right, please follow what I'm going to do. So we have a collision here. I'm going to go to a new page. We have a collision so that you understand the scenario before we start calculating. We have a collision of a steel ball and a small crate. A steel ball. Boom, they collide. But by the way, and after collision, definitely, we're going to have that object moving to the right. Let me look for. Okay, this then moves to the right at 3,5. Okay, 3,5 meters per second, which is the final velocity. Its initial velocity is 0. Do you notice the examiner says we should calculate? Let's look for what we are calculating. Calculate the velocity of the steel ball immediately after collision. Oops. After means final velocity. We don't know. My dear learners, do we know the initial velocity? Can somebody help me? Do we know? Oh, wait, hold on. m1 vi1 plus m2 vi2 equals to m1 vf1 plus m2 vf2, object 1 and object 2. Do we know the mass of object 1? Yes, 0,5. Don't write yet, don't write. What is the initial velocity of object 1? Object 1 has moved positions. Let me take this down. Object 1 has moved positions. Don't write yet. It was here. Then it came here. All right? Here, the velocity 0. Velocity is 3. Okay? So the object keeps moving. I'll use dotted lines to represent this movement. And then there. It makes sense, right? Ah, beautiful. All right. Mandlen Kosi says 3 meters per second. Guys, do you agree with 3 meters per second? Lane, you agree with 3 meters per second? I mentioned something. All right, guys, I mentioned something which means you guys did not take notes. Let's go back. I mentioned something, and probably let's go here and write it down. Let's go here and write it down. I mentioned something. Go back to this first diagram we had and write this. As the object moves, or as the object falls towards the ground, it gains kinetic energy. Therefore, velocity increases. Rory sang 0. How can it be 0? If both objects are 0, they will not collide. Does that make sense? Two objects cannot have initial velocity of 0. Let me explain that to you. Guys, can I move the screen? I want to go to that other part. Have you written that note down? That as the object drops, I did mention that, but let's put it down now. The object increases in velocity. All right, Sentike says it's more than 3, thus it should be calculated. All right. Clash says we should use the same mechanical energy calculated. All right, TN has taken over the class. TN. All right, so we are going to listen to TN. Meneer TN. All right. Okay, so we've written down this note, right? Okay, now I'm going back to the question now. So guys, please understand, as the object moves down, velocity is increasing. Are you seeing that, right? That's why we said that object starts from 0, it starts moving. Velocity is increasing 1, 2, 3. That means by the time it reaches this point, the velocity must be greater than 3 because mechanical energy must be conserved. It means we do not know the velocity at this point. At the point of collision, we don't know. Thus, that velocity must be calculated. Please, are you okay with my explanation now? As the object goes down, velocity increases. That you will understand more when we do vertical projectile motion. Because this is an isolated what? System. All right. It means, Lynn, are you fine now? Lynn? You okay? All right. So, guys, we do not know the velocity at that point. Okay, so we have a problem. Check this. We have a very big problem. We don't know this velocity. All right, this is going to be 0. We are looking for this velocity. This we have. So we don't know two things. My dear learners, we have to first find the velocity. Let's call this point A, point B, and point C. We have to find the velocity at point C. So let's show you how to do that. We find velocity at point C. This is where we bring in the law of conservation of mechanical energy. And remember what I said? The mechanical energy at point A is the same as the mechanical energy at point B. And that is the same as the mechanical energy at point C. So I would then have to say, E mech, since I know the E mech at point B, that we calculated 5,19. Do you remember? And we know because it's an isolated system, that should be equal to E mech at point C. Half M V, no, we know this already. We know this. 5,19. Remember, we calculated that. Half mvi squared plus mgh. My dear learners, please, I want you to now listen to my substitution. 1/2. What is the mass? 0,5. This is VF, not VI. VF at point C. All right? We do not know that velocity. Are you with me? All right. In any point of physics, is it possible for kinetic energy? Yes, absolutely possible, Josh. Very possible. Very, very possible. Okay. What is M? 0,5. What is G? Now, guys, we are talking about point C, where the object is actually on the ground. The examiner says the lowest point. What do you think the height on the ground will be? Offensive, that was fast. It's like you were waiting. All right, thank you guys. The height on the ground is 0. So let's do maths now. Do you notice we can get the velocity at point C now, right? Velocity at point C. Depends on how you want to do the maths. All right. I'll just show you the steps that you can do. I would say 0,5 divided by 2. Or why am I saying times 2? All right. Doing the right-hand side, which is 0,25. I want to make it easy for everybody. 5,19 equals to 0,25 VF squared. Already I know the whole thing there is 0. So what do? I divide both sides by 0,25. 5,19 divided by 0,25, right? But because it's a squared, what do? We find the square root of that answer. All right. For now, guys, please listen. I am not done with my calculation. It's only a means to an end. I am not done yet. Is that okay? Here, I advise you to write up to at least 4 decimal places because we are not done. We only round off once at the end of the calculation. Here we are not done. So please maintain up to 4 until the end. This is 5563. 4,5563. Talk to me. Are we okay, guys? Talk to me before we continue. This is the final velocity now at point C of the ball at point C. Oh, sorry, I missed your thumbs up and down. Somebody says I should repeat the answer. Okay, I was focused on my screen. All right. What do you want me to repeat? Is it the method? We divide both sides. 5,19 divided by what? 0,25. And then we find the square root. Okay. And I said because I'm not done, guys, once I start rounding off my answers, I start moving away from the correct answer. So I'm going to keep it at 5563 for now. 4 decimal places. Mandlankosi, are you okay now? Thank you very much. Now, guys, we are now saying, oh, object 1 collided with object 2. Now we can bring in momentum. Oh, M1 VI1 plus M2 VI2 M1 VF1. Now we all know this formula, right? M2 VF2. M1, which is the steel ball, 0,5. What is the initial velocity? 4,5563. I hope that makes sense. That is the velocity with which it collides. That's the velocity it has before collision. All right? Plus, what was the mass of the crate again? Mass of the crate, 0,1. All right. 0,1. But it was stationary. So 0. What is the mass of that thing again? 0,1. We are looking for VF1. What is the mass here? 0,1. And what is the final velocity? We were told it moves to the right at 3,5. Guys, is it making sense? Do you notice the rest is just now basic calculation of maths? Now we know. 7 marks, check. Bringing mechanical energy into momentum. The idea of mechanical energy was to be able to calculate the final velocity, all right, before collision occurred. Now we can do basic maths there, guys. You all, let's work out the maths. Work out the maths. Let me see your answer. Work out the maths. Quickly, everybody. Everybody, work your answer. Because I know some people are just waiting to copy answers. They are secretaries. Please, pick your calculator now and start working. Some people are secretaries. Let others do it. Now I'm just going to write the answer. That's why I'm not doing it. I need you to do the maths. Once you're done, please give me your final answer for VF1. I need at least 5 answers or 6 for those of you that are working and practicing. And it's important that you're not waiting. We are all doing it. You're putting hands to paper. Ofenti has given us 3,86. 2 decimal places for Nanani, 3,9. All right, I need more. 3,86. All right, Sentike 3. All right, Siviwe 3,86. Okay, so we can work with that answer. But let's see, what would I have done as a person? All right, I would have said 0,5 times 4,5563. That's on the left-hand side, right? Okay. Now I am going to bring in that other one from the right-hand side to the left. All right. The 0,1 times 3,5. If I bring it from the right to the left, it becomes minus. So 0,1. I hope my maths make sense. There we go. 1,92815. Then I would divide. All right. We've got a lot of teachers here today. I would then divide by what? 0,5. All right, 3,86. Beautiful. 3,86 meters per second. And it's positive. 3,86 meters per second. Since it's okay, we need to go back to the question and check. Are we looking for velocity or speed? But let me see. Somebody else might be sharing now by mistake. Don't worry, guys. That does happen. So don't feel, Are we looking for velocity or speed? Velocity. Guys, check 7 marks. Beautiful. Can I quickly get your response? Are you okay with this question? Let's see. I'm being told there were a few wrong units. Let me check. All right. Yeah. Being called attention Funanani, meters per second. All right. You didn't put the -1 to the power of -1. We know you cannot write exponents here, but just put -1 there. All right. Lumka, no unit. Patricia, unit is wrong. Guys, once your unit is wrong, you lose the whole answer. Okay. So please, let's pay attention to that. And also the direction, because the examiner is looking for velocity. Examiner is looking for velocity. All right, so Funanani, Patricia, Lynn, yeah, just to name a few. Okay, please don't be lazy. Don't be lazy. Don't be lazy. Let's write, because once we start getting lazy, we're going to get used to it. And we don't want to allow complacency. Okay, Zen, your end is up. Zen. Are we okay? Please, if you are just joining today, it's going to be quite hectic, eh? We've traveled a few... Okay, it's a mistake. All right, we've traveled a few kilometers to get here. All right, awesome. So we've looked at a very good example. I quickly want to explain. Let me see the next one. I want to explain something. Oh, let's try this one before I explain what I want to explain. Let's try this one. No problem, Zane. Thou art forgiven. Let's see this one. There's a hand again. Somebody raise the hand quickly. Let me know before we move to this one. Then I will talk about the change in direction. Okay, Clement Fato, you are forgiven as well. During an investigation, a police officer fires a bullet of 15 grams into... Please, guys, when I read and I see something wrong, I quickly change it. 15 grams is wrong. Can we stop reading and change that 15 grams? Can somebody tell me what's correct? What's the correct answer there? We convert by dividing by 1,000. All right. So what's our answer? Thank you so much. Mass will be 0,015 K. Please don't continue. You stop, fix it. Thank you so much. All right. They said 15 grams into a stationary wooden block. Okay, stationary. Velocity here. Can you see what I'm doing? I'm interpreting immediately. All right. Of mass 5 kg suspended from a long... Okay, now the bullet goes into the wood. The wood is the one that is suspended. The bullet remains stuck in the block system. And the bullet block, so the objects move together as a unit. All right. Swings to a height of 15 centimeters. Another problem. Physics. We do not work with centimeters. How do you convert centimeters to meters? We did not talk about that, so I'm glad this came up. Somebody help. How do we convert centimeters to meters? Anybody? How do we convert? Give us the conversion. Thank you, Clash. We divide by 100. Sweet. Well done. Lovely. Some of you that don't know, you're not sure, please write that down. We divide by 100. 15 divided by 100. All right, and that is... Yes, sir?
I would like to add on that particular one of the convection, especially the distance ones. Let's try to teach them go to the proximity and using the exponential form, because this will be very beneficial to them when they are also doing it. So say then be multiplying 10 to a negative 2, and then they see just like that. Yes, it is like that. That is 10 multiplied by negative. Yes, in that way as well.
All right.
This is true for the number of people.
All right, guys, I hope we all heard that, right? So you can also multiply it by 10 to the power of negative 2. So please, we convert. Let's learn all of those conversions. We converted kilometers per hour to meter per second. We converted what? Grams to kilogram. This one as well, you could have said 15 times 10 to the power negative 3. Okay? So, and centimeters, what I normally do is when I get to centimeters, then I ask myself, how many cents make 1 rand? It's 100 cents. So if I give you 100 cents, how much have I given you? I just divide by 100. Make sense? To convert into rands. And that's why when they say 59.99, have you ever collected that change? You go and buy something and they say 59.99. I always tell them, guys, just tell us it's 60 rand. Don't tell us 0.99, you know? Okay. All right, so guys, please learn all of these conversions. Write them down at the back of your notes, at the back of your page. Please write them down. Write all of these conversions that we've done. Kilometers per hour to meters per second, grams to kilograms. Now we've added centimeters to meters. Take note of this. You might just need to go back and revise those little concepts. Thank you, sir, for that addition. All right. Okay. It says it swings. Where are we? We saw that 15 and we stopped. So let's read again. The bullets remain stuck in the block, and the bullet block system swings to a height of 0.15 meters above the equilibrium position as shown. Okay, there we go. Effect of friction and the mass of the cord may be ignored because we don't want to cause a change in mass. Look at 4.1. Everyone is now getting 4.1. Everyone in this session. Everyone is now getting 4.1. Correct. State the law of conservation of momentum. What is it? In an isolated what? System, the total linear momentum is conserved. 2 marks. There we go. Quick 2 marks. Use energy principles. Okay, let's see. To show that the magnitude of the velocity of the bullet block system. All right, let's listen to this. Energy principles. Remember, we spoke about mechanical energy, so that's another word. Energy principles. Use formulas of energy. That's what the examiner is saying. Use formulas of energy to show that the magnitude of the velocity, let's read carefully, of the block bullet system. So examiner is already referring to this thing here. They are already referring to this. All right? Bullet block system is 1.71 meters per second immediately after the bullet struck the block. Okay, let's calm down. This is where you calm down. Okay, what are they really asking for? The examiner is referring to something. The block bullet system. Where was the first time we had a block bullet system? This is the ground. Where was the first time when the bullet hit the block? So this is where we have the bullet. This is where we have the bullet block system. I don't know if it makes sense. The bullet hit, thank you, Bokan, during collision. That was the first time we had that system. Okay, wait. Let's see. Pa. What are we looking for? We are looking for the velocity of the bullet block system. The guys, oh, by the way, when they ask you to show, I have seen some learners use what they ask them to show. Guys, you don't use what they ask you to show. The examiner is helping you to say, this is the answer you should get. Is that okay? Show. So in this calculation, I'm not expecting you to write 1.71. You are supposed to get 1.71. But let's see. All right. We know that the height here is 0.15 meters. I mentioned something earlier on. At the maximum height, let me show you. And this is why your notes are very key. And I try as much as possible to always mention. Check this. What do we know at maximum height? At maximum height, so if you have a highlighter, highlight it. Velocity is 0. This time around, the object is going up. But at the maximum height, again, that will be emphasized when we talk about vertical projectile motion. I think term 2 or so. At the maximum height, the velocity is equal to 0. Great. So, we know that the bullet block system, therefore, has a has a velocity of 0. Right here. Velocity equals to 0. Why? It is at the maximum height. Maximum height. That's why the examiner gave us the word equilibrium position, which means object is no longer moving. If you remember that word from grade 11, when forces are at equilibrium, it means F net is 0. Okay. Great. Blah, blah, blah. What are we looking for? We are looking for the velocity at the bottom, VI. We know our final velocity is 0. Energy principles. Oh, sweet maths. We can now use mechanical what? Energy. E-mech at the bottom is now equal to E-mech at the top. Does that make sense? So, E-mech, we can say initial would be equal to E-mech final. What is E-mech? It is EK plus EP, all right, initial equals to EK plus EP final. Are we together? Now, what is EK? It is half mv squared plus mgh initial equals to half mvf squared plus mgh final. I'm forced to go to a new board now. So guys, we are using the formula and all we are doing now is we are substituting. All right. I'm going to keep this board and just take this one out. I'm going to take this one out. Can I? Yeah, I can. So let's write all the calculations now here. Sweet. Half. Now, my question is, I cleaned it. Let me go back, guys. Please look at the mass we are looking at. What are we looking at? We are looking at the mass of the bullet and the block together. Bullet block system. That's what we have here. And that's the same mass here. So what do we do to the masses? Can somebody tell me? It's called a bullet or a block bullet system. What do we do? What's the mass? Mass of the bullet block system. Somebody, someone. Somebody talk to moi. Mass. What do we do with the mass? Njabulo. Why 5? Jabulo, why 5? Just a question. I'm not saying you're wrong, but why 5? Okay, what is given? 5 is the mass of the block. But what are we talking about? Bullet block system. Bullet block. It's the bullet and the block. Lean, why do we subtract? The block is 5. The bullet is 0,015. Now we are joining the bullet and the block together. Is it becoming heavier? Okay. Awesome. Jabulu, are you fine now? That we add. All right, guys, it's like you weighing 50 kg. Your mass is 50 kg. And you have a school bag. Some of your school bag weighs more than you. All right? Now, once you take your school bag, what happens to your entire body mass? Yeah, sometimes I just look at, oh, this bag, this child is dying. All right. So what is the mass? The bullet block is the addition, 5 plus 0,15. Okay. I hope that makes sense. 5,015. Are we right there? Do we know that velocity? Nope. Plus. Now, they are still on the ground. The first time we heard about the collision, they were on the ground. And what do we know? The height is equal to what? 0. I'm going to throw all... Okay, this is getting... I don't like it. I'm squeezing things. I don't like squeezing stuff. I don't like squeezing stuff. But it's fine. Because I wanted to have the question at the back of your mind. 9,8. And this is... No. My OCD is already playing a big... We'll come back to... Okay, I want to take this question out. Fulu, your hand is up. Talk to me.
Yes, sir. I just want to ask that where did you get 5,015?
Okay. That's what we are explaining so far. Keep your mic on. Keep your mic on quickly. Hi.
Okay.
How are you?
Hi, sir.
Are you
fine.
okay? All right. What are we looking at? What are we looking at? Yes, you're saying something? Go ahead.
Yeah, I want to ask where did you get this 5,015?
Okay, what are we looking at?
I don't know.
Okay, child. What are we looking at? We are looking at what? Can you see what I'm circling? Block. What happens to the bullet when it enters into the block? It stays there. Can you see it stays there, right?
Yes.
Okay. So, like I was saying, let's say you as a person, your mass is 50 kg, right? And then the mass of your school bag is 10 kg. Now, when you carry your school bag, what's the total mass?
You is 5 kg and the other mass.
Danko, you are too smart,
And
man.
my mass is...
You got it now, right?
Yes.
Awesome. You're welcome. It's the bullet block system. So 5 plus 0,015. You are most welcome. I love the questions you guys are asking. It shows that you're following. All right, so we're substituting there. Guys, I hope you understand where this 0 comes from. Object is on the ground. Equals to 1 over 2. Again, 5,015. Now, final velocity. We remember we had a diagram. The object is now at the top there. All right, there we go. There we go. Maximum height. So our final velocity is 0. Then what do we have? Plus mgh. What is the mass again? 5,015. What is G? 9,8. Now, I told you that height is always measured from the ground. If you remember, we're given 15 centimeters. And that is, we got 0,15. Let's do the math now. Look, this is 0. Don't even waste time. That is 0. Okay, what is half of 5,015? Everybody, we're working. Somebody give me an answer for the one on the right. I'll do the one on the left. Somebody give me an answer for the one on the right. 5,015 times 9,8 times 0,15. I will do the one on the left. The one on the left, 0,5, 5,015. All right, the one on the left is 5075. 2,50 that. Is somebody giving me the one on the right? Can somebody else confirm? Jabulo gave. Guys, don't round off, please. Don't round off. Don't round off. I already say Lane. Lane, don't round off. Okay. 7,37205. 7,372. Don't round off. I said we only round off when we are done. 37205. 372. Okay. And you guys are giving me that same answer, so I'm taking that as a correct answer. Let's see. What do? We divide both sides by what? 2,5075 and find the square root. Let's check. I hope you know the math, right? So it is 7,37205 divided by 2,5075. Okay, but it's VI squared. What do we then do? We find the square root of that answer. And what's our answer? Yay! 1,71. Ta 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 da. Ta 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 da. Ta da da da. Ba ba. If you guys were here, you'd see me. I'm on the table right now. Ba, 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 because the examiner says, and that's how you feel in the exam. Show, like, who's the boss now? You know, 1,71. And guys, it's not 1,72. Yes, Refiwe, talk to me. Pa, 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 pa. I should have a vuvuzela here. Yeah. Refiwe, your hand is up. I'm going to get a vuvuzela, I promise you. When we get it right, we just blow it. Yes, Refiwe, I'm waiting for you. You are the one I'm waiting for. Fifi? Bualina. All right, sir, the calculator. Okay, sir is saying we should teach them the calculator skill. But I'm just looking at some learners, add when they're not supposed to add. And that's why I want to just show them the steps first. Okay, and we are just emphasizing, guys, please do not round off until you are done. Okay. Mr. John. All right. Okay. Because I noticed that some learners are doing physics, but their maths is still a bit sitting on a wheelchair. So I want to show the steps on the right-hand side and the left-hand side. Thank you, sir. Okay. Refilwe raised up a hand and boom, ghosted us. Fifi, we're waiting for you. Okay, you let us know if you are still lost, if you need any assistance. We are here to guide you. There are a lot of teachers on this group, and I'm receiving messages. That's why I'm reading them to you. Okay, but guys, please take note, no rounding off within a calculation. If you remember the other time I did that calculation, I had to say 4 decimal places before. All right. Mr. John. Okay, guys, what's our answer? 1,71. Yay! 1,71 meters per second. That's what the examiner asked us to show. I hope you guys see the importance of mechanical energy now. When do we use mechanical energy? You must have a height, and it must be an isolated what? System. Please read the question well to know which formula you are using. Am I using momentum here? Am I using mechanical energy there? Awesome. All right. Please, we're doing a lot of hard work. Don't mess it up with the other little mistakes. Now, 4.3. Let's see. Calculate the magnitude of the velocity of the bullet. Oh, examiner is now focusing on the bullet. All right, somebody says, why is it not 1,72? It was 1,714. So what you do is you count two numbers after the decimal, 71. The next number, if it's not up to 5, you don't change the value. It was 1,7146, right? 2 decimal places. I'm going to stop here. Now look at the next number. The next number is a 4. If it is less than 5, it doesn't affect it. Tokozo, are we okay? That's how we round off, guys. And good question there. So we all learn. Tokozo, quickly, I need to find out if you're okay. Just give me a thumbs up or thumbs down, you don't agree. Great. So, guys, let's take note of that. That was a very lovely question there.
Yeah.
Yes, sir?
I don't know. I like that question from people also. And then, not teaching next anymore. I'm wondering whether this one has to be from next. There is this pattern that they like to do. They go to the last digit after the comma and check it. And then it will either add to the next one and it will do that up to the second after the digit. That's what I think because of that.
Yes.
It's at the last digit. Yeah, and then they carry over and over and over and over.
Yes.
That's not how it
That's what Ntokozo was thinking. Guys, let me quickly re-air that. What you did as to get 1,472 was, we stop here. Then you check the 6 here. No, don't worry about what is there. Worry about the one that is immediate after your 2 decimal place. 1,71. You stop. That's why I have this black. Then this is what counts. If this was 1,715, then this should have been 1,72. Okay, guys? All right. Please, that final answer is very important, eh? How we round off. And remember, write it down in your book. You only round off at the end of the session. All right. Okay, let's quickly run. Let's run because there's one more concept I want us to look at. And I see it already. We only have about 30 minutes. Ooh, time is flying so fast. All right. Calculate the magnitude of the velocity of what now? The bullet. Examiner is now focusing on the bullet. Guys, where do we have the bullet? The bullet, we have the bullet before the collision. Does that make sense? The bullet existed only because the examiner says bullet. Just before it strikes the block. Okay, let's see. Let's extract this out. Let's try to make it easy for you to see. We are now focusing on the bullet. Question is, where is the bullet? Where is the bullet? So the block was here. Okay. We have the bullet. This is where the bullet existed. The bullet existed here. Oh, okay. And at the end, both of them now moved together. So they were separate before and together after. Do you remember our formula? Okay. Sum of initial equals to sum of final. Because they were separate. Lesson 3. If you guys remember lesson 3. What do we have? M1 VI1 plus M2 VI2. Now they are together. M1 plus M2. This was why we're adding VF. And oh, by the way, we forgot something because we're now used to it. We're choosing this direction as positive, right? Guys, we just forgot all of that. Bullet being 1, block being 2. Do we know the mass of the bullet? Yes, 0, 0. Be careful of the zeros. Do we know the initial velocity of the bullet? We don't know. Do we know the mass of the block? 5. But it was stationary before collision. 0. Now what do we have? 0, 015 plus 5. Now we were told that this thing moves at 1,71. Do you notice? We couldn't have gotten that 1,71 meters per second without the law of conservation of mechanical what? Energy. We had to use that to get that 1,71. This is why I am combining saying energy and momentum. 1,71. Okay, do you want to do the maths for me? Quickly, everybody, do the maths. Let's see. Do the maths. This should not take you more than 45 seconds to punch your calculators. It's important that everyone is calculating. Don't wait. Don't wait. Somebody's waiting for others to give answers. No. Calculate. If you are wrong, we will assist you. That's our job. But if you are thinking, I assume that I know, guys, it's just this thing. Just press your calculator. Exam will show you. All right. Okay, I'm having 2 different answers already, and there's a problem. I have a 334,33 meters per second. Ntokozo, you gave me 8,57 without a unit. We are going to start fighting, guys. Rebecca, 571,71 meters per second in the direction of motion. I need more. Quickly, I need more. Please. Answer with a unit. Are we looking for speed or velocity? Let's go check again. So we can conclude the magnitude of the velocity. Okay. Magnitude of the velocity. Come, I need the maths. 571,71 Sentike, Siviwe, Rizana, all right. So, Ntokozo, please let's check the maths. Let's check the maths. Something might be wrong somewhere. Courtney, let's check the maths, please. All right, I think 571,71 takes, all right, okay, Offense is also saying. So what do we do? This one is 0,015 VI1 and that. Okay, I want to show you something. I think this was what Sir was also saying at the other time. 5,015. I want to show you something here, times 1,71. But this, you must just know your maths. Once you know your maths, it becomes very easy. All right. Look, if you know what you're doing, you don't really need to write everything down. You can just go ahead and say divided by straight using that answer button. Okay, I actually prefer this one. Answer. Because I am dividing both sides by, what am I dividing by? 0,015. 571,71. 571,71. All right, 571,71. Okay, you forgot the 1,71. All right, let's see. Abigail, Please, your unit. Don't be lazy. You are forgetting the -1. It's per second. Rebecca, same story. Please, don't be lazy. We know you're not writing exponent, but write it out. Okay, 571,71. Can I just write that final answer? 571,71 meters per second in the direction of motion. Guys, we are emphasizing those units. You would be losing marks. You will have done the hard work and then you come and lose mark on units. That doesn't make sense. So please, let's keep writing the units. Guys, are we okay? And that's the thing there. Makes sense, everybody? Let me know. Are we okay? We have 4.4. Then I want to explain one more concept, and then we would say adios for today. Sir, aren't they looking for? Oh yeah. Calculate the magnitude. Okay. We're looking for the magnitude. All right. VI is 571,71 meters per second. Magnitude. Thank you, Lebo, for the reminder. Magnitude. All right. For those of you that are not participating and sharing your answers, we are not picking your mistakes. You see, like those we have called, they would remember, oh, sir called me. Like I said, guys, I'm not the only teacher on the group right now, in the class right now. So there are teachers who are checking your answers. And correction is one of the best ways to learn. So some of you are keeping quiet. They are going to laugh at me. No one is laughing. Put your answers there. Let's see your answers. Once we correct you, you'll be able to be like, oh, I was corrected. So please don't be shy. There's nothing wrong in getting a wrong answer while you are in class. It is the learning process. It only becomes a problem when you are now doing an assessment. But while we are still studying together, let us get the correct answer. Let me go and check something here. Ntokozo, please talk to me. Did you see your mistake? Oh, great. Beautiful. Thank you. I love that. Now you've been corrected. You know what to do. All right. Let's look at the last one here. The last question. The police office... Okay, I've got a mic that is on. Kituneti. All right, thank you. Once your mic is on, it gives me a feedback here. So, okay, I've got a question from Valencia before we move on. So basically, we don't put direction when we are looking for magnitude. Yes, magnitude means size. Magnitude means the size, the number, the value. All right, 4.4. The police officer is pushed slightly backwards by the butt of the rifle. Okay, many of us have not shot guns before. All right, but when you shoot a gun, you can Google it. All right, there's what you call a recoil. The person who shoots the gun. So if you go and that's why they go for shooting range. You can't just say, okay, you see in movies how they shoot a gun. If we give you a gun, you're going to fall down. So the shooting range is meant to train you. There's a way to shoot a gun. All right. When a gun is shot, I wish I had a GIF here. Well, I've shown you. There's a recoil. The gun pushes you back a bit. And if you're not standing very well, you'll fall. That is called a recoil. All right. Now, the police officer is pushed slightly backwards by the butt of the rifle, which he is holding against his shoulder. All right. Whilst firing the rifle. Use the relevant law of motion to explain why this happens. Anybody? Why is that when you shoot a gun, it pushes you back? Let's see. Anybody? What? They said use the relevant law of motion. Which law? Okay, Nini, you have a question mark. You're using a question to answer a question. Is it Newton's third law with question mark? All right, but I'm so... Yes, Tepiso Copano? Tabs. Tabs. Your hand was up. All right, guys, I'm glad at least you know the right law to use. Awesome. You know the first way to get this question right is to know the correct law to use. And I'm so proud. We are proud of you guys. All right. We're proud of you guys getting the law correct. Good. Use the law to explain why this happens. So let me try to give you that answer. All right. I think it's 4.4. Okay. All right. According to Newton's third law. All right. Look, for saying that alone, 1 mark. For just writing according to Newton's third law. The fact that you have mentioned that law, you already have 1 mark. Okay. The bullet exerts a force. Let me start with the gun. Sorry. Because let's see, the rifle exerts a force because it's been pushed. Exerts a force on the bullet. And simultaneously, do you notice we are in a way stating the law? The bullet, all right, exerts an equal or a force, exerts a force on the rifle, okay, which is equal in magnitude, but opposite in magnitude. Why am I writing magnet? Magnitude. And opposite in direction. You're actually done. You're done. The force pushes the policeman backward. So guys, whenever you are doing a physics explanation, please use laws. Don't come and write English. Okay. We use appropriate laws to explain physics answers. Everybody okay there? All right. Now, the last concept, which is very important that I need to expose you to. Look, every other thing you would see would be based on what we've done in these 5 days. The last concept would be this. I'm switching my screen now, switching board. When an object experiences a change of axis, I'll explain what I mean. When there is a change of axis, I'll tell you what I mean now quickly. All right. When an object moving vertically, I'll write this in capital, suddenly changes and moves horizontally. Please. Horizontally. Its initial velocity on the horizontal axis That is, at the point of change of direction, is 0. Let me write that in capital. 0. It's just a little trick that examiners are going to want to use to throw you off. Let's make this a yellow one. All right, I want to explain with these diagrams. And then I think I've seen about 2 questions on this. So guys, we've done simultaneous, we've done a bit of graph questions. There are so many other graph questions. All right, but time will not allow. I'm praying. You know what my prayer is? My prayer is that at school, you will not use any of these questions that we've done here, so that you would be exposed to other questions and you increase your work. Rizana, your hand is up. Thank you, Mr. John. Thank you, sir. Yes, Siviwe, I'm going to post. Yes, Rizana.
Can you explain? You said when an object moving vertically suddenly changes and moves horizontally, is initial vertically?
Oh, it's initial velocity. Sorry.
Yeah.
It's initial velocity. I don't know why I wrote vertically again. It's initial velocity on the horizontal axis at the point of change of direction is 0. Please, I want you to listen carefully. Thank you so much, Rizana. And I want you to listen carefully because I'm linking what I've done earlier on with this. My dear learners, please, I want you to listen. This object starts from here and goes vertically downwards. Vertically means straight. All right? At point A, okay, let's say point 1 or point A, and then gets to point B. Now, somebody is saying, didn't we just do the law of conservation of mechanical energy? Please listen. Yes, we just did that. As the object is moving down, the velocity is actually increasing, right? But this is a vertical movement. When it gets here, let me use values. Velocity here is 0. When it hits down here, let's say velocity is 10. But now there is a change in axis. I'll go back to my mechanical energy and show you the difference. Vertical and horizontal. Once this happens, now this object is moving this way, right? The initial velocity of this here going this way is 0. When there is a change of axis. Now, before you start judging me and start telling me thumbs down, listen to this next statement I'm going to say. When we did mechanical energy, I did explain first the mechanical energy, right? I did explain the mechanical energy. However, do you notice we did not change from vertical to horizontal? We were using, it was a curve, the questions we answered. Here, you will use the law of conservation of mechanical energy. Here, the object, conservation, the object is not changing axis here because it wasn't moving vertically. Vertically means straight down. Please let me know if this makes sense. Please let me know. Understand the movement between the two. Understand the movement between the two. Blessing, Njabulo. Okay, please listen carefully. I'm going to repeat. I am going to repeat. Please, I am going to repeat. What we need to first define is the word vertical, guys. When we say something is vertical, it is straight. It forms an angle of 90. Let's quickly understand that. So, when an object moves, all right, and changes axis, we have a 90 degrees. The object cannot go horizontally without stopping first. Every time an object changes direction, it must first stop. It's a law of physics. It's a law of physics. You will do that more when we get to vertical projectile. If I throw an object up, you are expecting the object to go up and come down, right? It goes up. There's the change of direction here. It must stop first. That's why at the maximum height, velocity is 0. The object cannot turn without changing direction. Up it goes. Once it wants to come down, it must stop before it comes down. Now, an object is coming down, all right? An object is coming down. It wants to move horizontally. It must stop before changing direction. So the velocity horizontally will be 0. Please, are you okay with that explanation? Are you okay with that explanation? All right. Did that make sense? Okay, Seth just sent me something now. I want to check because I was looking for a GIF. All right. Okay, I'll post it on the group and you would see the recoil. Okay, when you shoot a gun, yes, you would see the recoil. Beautiful. I'll send it to you guys now on the, when you're done. Okay, I'll send it on the group. I'll send it on the group. Okay. You can watch what we mean by recoil. Don't worry, I sent the link now, but I'll send it again on the group. Okay. Let me just, we'll share on the group. Okay. All right, because I was trying to save time. All right. So, guys, an object will not change direction until it stops. It must stop first. Although it doesn't look like it stops. But some of you drive and you tell me, oh, if I'm reversing, then when I want, I just put it in one and the car goes. No. Physics. The car must stop before a change of direction. So, when it's a vertical axis, vertical and horizontal, the initial velocity horizontally would be 0. When I come to the right-hand side, guys, this thing is not vertical. Look, this one was not moving vertically. Please take note. Let me go back. Let me show you. This was not a vertical movement. It's an angular movement. Look at this. The ball was not moving vertically. The ball was not moving vertically. Do you see the difference, guys? The ball was swinging down. There's an angle there. All right. It's not. If it's vertical, it will come straight down and then go left. Please let me know if that makes sense now. Let me know. Talk to me quickly. We're finishing now. You understand the difference between the two now? It's a law of physics, guys. It's a law of physics. Object must stop before a change of axis direction. If it's moving down and it wants to move right, it stops first. If it's moving up, it wants to come down, it stops first before changing direction. But in this case, the object is swinging. It's not moving vertically. That's why we needed this velocity. Let me do one question on this, because I'm trying to cover all the types of questions that you may come across. There is one that I had. Oh my God, guys, I had lots of questions too. Oh. Please, I'll send this. I'll try to send you the answers. We did something similar. You remember this one? So you should be able to do this. This is very similar to that one where the bullet and the block system. All right, so I'll leave you with that. I'll send them through to you. I want to do this one. Look at this one. And this will be my final question for the day. A trolley of mass 5 kg. Okay, we're going to do it very fast. A trolley of mass 5 kg moves at 4 meters per second east. Look at the diagram. The diagram is always there. Always use the diagram, guys, to understand what the examiner is saying. The diagram is always there as a guide. A trolley of mass 5 kg moves at 4 meters per second east across a frictionless horizontal surface. Frictionless means the system is isolated. A brick of mass 1,5 is dropped onto the trolley. All right. So what do you notice? The trolley is moving horizontally downwards. It hits the trolley and they both move. There's a complete change of direction. This one is a vertical movement. Let me know if you see the difference, the vertical movement now, quickly before I calculate. The vertical and the angular. Do you see the difference? Please don't forget what I just taught you now. It's very key. There were 2 hands that were saying thumbs down. Jabulo, are you fine now? It's a physics concept that I just taught you. All right. So in this case, you would see that this thing was moving vertically and then horizontally. There is a change. Vertical means straight. Horizontal means straight there, 90 degrees. This object must stop before it moves. All right, Njabulo, it's a physics concept that you need to write down and assimilate. The object stops before it changes direction. An object must stop before change. When you do vertical projectile motion, you'll come back to this topic. All right? If you throw an object up and comes down, don't think it just goes up and comes down. No. As it goes up, it reaches a point, maximum velocity, and then, maximum height. At this point, the object stops. Velocity is equal to what? 0. Physics concept. If the object comes down and then automatically starts moving like this, it must stop before it moves to the right. Coming down, velocity is increasing, blah, 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 blah. When it gets here and it needs to move in a new frame of reference, that's the right word, the velocity is 0. All right. So Jabulo, please take that physics concept and run with it. Guys, I'm going to skip 4.1. Define in words the law of conservation of momentum. Everybody should be fine with that now. Number 2, state the condition for an elastic collision. What is the condition for elastic collision, guys? What is the condition for elastic collision? We did that yesterday. Condition for elastic collision. Talk to me, anybody. Anybody? Does anybody remember? What is the condition for elastic collision? Hello? Are you guys still there? All right. Kinetic energy is conserved. For collision to be elastic, both momentum and kinetic energy are conserved. All right, so that is good. Can we move on to the last question? No energy is lost. Thank you, Jabulo. No energy is lost. Both kinetic and momentum are conserved. I prefer us to write that answer as both kinetic energy and momentum are conserved. Calculate the change in momentum of the 5 kilogram trolley. Examiner wants us to calculate what? The change in momentum. How do we calculate change in momentum? Let's see, 4.3. Examiner wants us to calculate the change in momentum. What do we know? It is m delta v. It is mass, final velocity minus initial velocity. Of what? Which one are we looking for? We're looking for the trolley, all right? So if it is, which one is the trolley? Okay, so I'm going to write trolley here. trolley, and trolley. Remember what we had so that we don't go forth and back as I'm trying to finish right now. This is what we had. We had a trolley and a brick. Okay, so this is our trolley and the brick. So we are looking for, and the initial velocity of the trolley. Okay, mass is 5 kg. And what is the velocity of the trolley? The trolley was moving at 4 meters per second. All right. Let's read something again quickly as we just get our values. A trolley of mass 5 kg moves at 4 eastward, which means that its initial velocity was 4. The question is, for us to calculate change in momentum, we need the final velocity, and that's where our challenge would be. Our initial velocity is 4. What is the final velocity? Because the mass of the trolley we have. What is causing the velocity of the trolley to change? There was a brick. Right? Now, we need to first, step 1 is to calculate the final velocity of the trolley using what? Collision. So M1 VI1 plus M2 VI2. Now the objects are together. Okay? Or let me change my notations. Let me use brick and trolley. The mass of the brick, initial velocity of the brick, mass of the trolley, initial velocity of the trolley. Now both of them after collision were together. All right? Final velocity. Do we know the mass of the brick? The brick is 1,5, I think. Yes. Remember, the collision happened on a horizontal plane. Don't forget. The collision happened on a horizontal plane. What's the mass of the brick? 1,5. What is the initial velocity of the brick? Horizontally, 0. Why 0? The brick was falling vertically and then changed to a horizontal movement. When an object moves vertically and changes into horizontal movement, its initial velocity horizontally is 0. Principle of physics. Plus, what is the mass? 5, 4. What do we have? 1,5 plus 4. No, plus 5. Now we don't know the final velocity. Let's do simple math. That is 0 there. This will give us 20. This would give us 6,5 VF. Is somebody giving me an answer quickly? Final velocity. Final velocity. Somebody, 20 divided by 6,5. We are done. Somebody please help. Your answer should be about 3, something. Yes. 3,0769. Thank you, Nell. I love that. That means, Nell, you are listening. Somebody would have, please guys, we are not done in Jabulo. We are not done. We have emphasized this. Don't round off answers in between calculations in Jabulo. 3,0769. At least 4 decimal places. Please. Once you round up, you are going to start losing answers. All right, here, meters per second, okay? But I'm not done. I need to now calculate the change in momentum. Mass of the trolley, final velocity of the trolley, minus initial velocity of the trolley. What's the mass of the trolley? 5. What is the final velocity? 3,076. What is the initial velocity? 4. Can somebody give me an answer? And it makes sense. Our answer is going to make sense. Our answer would be negative. It's making a lot of sense because the object is reducing speed if you go back to lesson number 1. All right, let me save time and calculate. So what do we have? If you beat me to it, I'll appreciate that. 3,0769 minus 4. Confirm my answer, everybody? Beautiful. Now we are done with the calculation. We can round up. Rizana, your unit is wrong. What are we looking for? Change in momentum. Lane, your unit is wrong. And many of you did not write units. Guys, we are going to fight. We are going to fight a lot. We are going to fight. This is change in momentum. What is the unit of momentum? Kilogram meter per second. Now, that is wrong. You guys, use the definitions to remember. What is the definition of momentum? It is the product of mass and velocity. Always remember the definition. Product of mass and velocity. Mass is kg, velocity is meters per second. So negative 4,62. Negative 4,62 kg meters per second. But are we looking for magnitude? Let's see. Are we looking for magnitude? Blah, blah, blah. No, we're not looking for magnitude. So we need a direction. So my answer therefore will be 4,62 kilogram meters per second in the opposite direction of motion. Opposite direction of motion. Guys, I've emphasized units, emphasized formulas, emphasized directions. All right, please, let's get it right. Use the formulas. Yes, we're taking the last set of questions before we log out. Please don't log out. The question might help you. Nolo, quickly talk to me. Your hand is up. I was wondering if it's possible to get notes of the previous lessons because I've joined today and I was able to catch up with you from the start of the lesson until question 4. Questions that followed after I got lost, what should I do? Or what was the last station on momentum? All right, Nolo, all the lessons are on YouTube. You go listen, watch the lessons and write your notes. I like it when you write. As you are writing, you are learning. We okay there, Nolo? I hope you are on the group. Are you on the group, Nolo? Or you just joined the class straight? If you are not on the group... Sorry?
I'm in the group, sir.
Okay, beautiful. I would reshare the links again for you so that you can rewatch. All right, especially group 2. Are you... Okay, there's another group, group 1 and group 2. I'll have to reshare on group 2 as well.
I'm in group 2.
Group 2. Okay, beautiful. Group 2.
Yes.
I would share so you can catch up. Lesson 1, 2, 3, 4. This is lesson 5. Please take time this weekend before school fully reopens. Watch, learn. Have questions for your teachers when you get back. Please, that's very important for everyone. All right, guys. I will send quite a number of questions. Yes, Valencia, talk to me. Quickly, we're rounding up.
Sene?
Yes.
So like basically, when we are doing law of conservation, if they say we should calculate change in momentum, we should first find like the initial velocity or the final velocity if we're not given.
All right. This is how I'm going to answer your question. Every time they ask you to calculate something, write down the formula. Then ask yourself, what do I need? Valencia, does that make sense?
Yes, it makes sense.
If the examiner says calculate change in momentum, you ask yourself, what's the formula for change in momentum? It is m vf minus vi. Okay, now ask, do I have this? Do I have this? Do I have that? If you don't have any of those, you've got to find them.
Yes.
And
So, Sani, it depends with what we have, and then you are gonna have to find it.
Yes.
With what you are given.
Absolutely. So it always depends on what you have, and what you have would determine what you would use to get what you need. Sometimes you will have to use F net delta T. So always write out the formula. You would say always write out the formula, and then I check which formula to use. Are we good there, Valencia? All right, guys. Awesome. Okay, guys, it's been a journey with you from lesson 1 up to 5. Tomorrow we have maths, just to catch up again on number patterns and do a few questions that may also be lovely for you. All right, that's what you see on the board there. Is our extra class information. If you want to continue with us in this stream for the year and then keep enjoying this on a weekly basis, then you would have to register. But now we are done with the full topic. We did quite a number of questions. As the year goes by, we'll still have some few sessions. But if you want to enjoy on a weekly basis, then register. I'll be sharing more information on how to register in the group. Tomorrow we meet same time for maths. All right. If there's no question, please do have yourself a very lovely, lovely evening. All right, Taiba, lovely. Thank you so much. Thank you for staying in. All right, good night, good night, good night, everybody. Thank you so much, Ma. Thank you, thank you, thank you. Really appreciated, Ma'am Mola. Bye, guys. Bye, Valencia. Courtney, bye. Bonolo, bye. Tokozo, bye. Nini, bye. Bye, Lumka. Awesome, Lumka. Talk to me on WhatsApp. All right, talk to me quickly on WhatsApp. All right, Label, goodbye. All right, I'll have to log everybody out. Oh, sir, you came back in. Thank you, sir, and good night. I'll share the registers once I get back into the office.